Hey everybody. Good morning. I'm just letting people in here. Let us jump into our check-in question. Um, our check-in question is cats, dogs, or question mark. If you have a pet, if you don't have a pet, you could put what is a pet you would like to have, anything like that. Go ahead and put it in the chat for our attendance check. All right, checking out the chat now. Let's see. So a lot of cats, dogs, both. Cats, good, yay, a bunny. I prefer bunny too. Dogs, a lot of dogs, turtles. Dogs, but cats are cool too. We got dog. I want a chameleon. Yeah, those are cool. Both dogs, but a pet I would like is a chameleon or an iguana. I agree, those are cool. They change colors. Cool, just double checking again. Make sure if you're here, you answer the check-in question so I could mark you. And then I'll double check who I have and who I don't have. All right, so let me go ahead and double check. This is who I don't have yet. Dennis. Ethan, if you're here, Ethan. And I apologize if I missed you, but I don't see your response in the check-in. Okay. Miles. Alacia. August. And there's one more, but let me double check. Yeah, and Latravion. Those are who I have so far absent. Again, if you're friends with them, let them know to come into class. I'm gonna go ahead and update the Power School, and I'll be with everyone in a second. Awesome. But anyways, as I'm doing Power School, go ahead and read through our agenda right here. And then I'll go through it right now in a second. All right, cool. So great. We had our attendance and check-in question. If you all remember, on Thursday, we started on Desmos and we were trying to model different situations. We're going to go back into that. You should basically, once you log in, it should put you to where you left off and what you had so far. I'm going to put up the codes in a bit. After we're done with the Desmos modeling situations, we're going to have a quick Padlet reflection on that activity, like to see like, anything new that you learned, something that you weren't aware of, things like that. And then after that, we're going to move on to notes on function composition. Maybe or maybe you have not seen this, so I'm not exactly sure, but it doesn't matter because either way, I'm doing it as an introduction. Asynchronous number 5 is due tomorrow. I got a text that I accidentally did not attach the actual assignment, so I fixed it. The assignment is now there with the attachment. Um, so asynchronous number 5 though is based on function composition, by the way. So if you looked at it and you're like a little bit confused, it's because we still need to kind of talk about what is function composition. But again, it's going to be due tomorrow at 11:59. But even if like, let's say I don't get to talk about it, I included links on how to do it, like video support and also like a website where you could look through it. But again, I'm hoping we could talk about it today so that you have no issues on that assignment. Let me know if anyone has any questions on the agenda. All right. Let's go. All right. So, by the way, as a heads up and as a reminder, when our asynchronous assignments due, always just go to Google Classroom. The due date should be on there for every single one of your classes. All of your 12th grade teachers were aligned. I know I have some 11th graders, but I'm hoping your 11th grade teachers are aligned, right? That they're always posting on Google Classroom, that they're always putting on the date there. But for me, my class, my asynchronous assignments are always going to be due Tuesdays, Thursdays, Sundays at 11:59 p.m. So that's specifically for my class. My due dates are just 3 times a week. So that's just a little heads up. And usually I post my asynchronous like 2 days before it's due. So it gives you like ample time to get it done. Great. All right, let's go ahead and log back into our Desmos. So we're period 1. So the code to log you back into your Desmos is this one here on the left side. So you're going to go to student.desmos.com again. So go ahead and open up a new window. And then you're going to type in this code. Let me give you all some time to get logged back into that. And then I'll be here on my phone to just see how many people we have logged in. We should have 24 people logging into it. Awesome. We have about 5 of us in there.
Didn't we do this one, Miss Adana? About the
Yes.
slide?
Yes, we did. We started it and we're gonna finish it basically.
Okay.
Yeah, we're almost done with it, but I definitely want to finish the activity. All right, cool. I see about 21 of us in there. We're waiting on about 3 more. I'm gonna go ahead and open up my teacher side of this. Right here. All right, and here's where we're at. Again, I anonymize the names, but again, if I unanonymize it, it does link your name to it. Again, I'm anonymizing it so that you're safe to share whatever sketches you have. So you could, on your screen, you should see what your anonymous name is if you're worried that your graph is not showing up. So as a bit of a review, where we stopped at was on this one right here, where water was filling up in this bowl, and then like out of nowhere, let me just replay the video for you all. Cool. And then where we left off is some of you went ahead and did your sketches, and I'm noticing like very similar sketches. So for example, this first graph right here, Jacqueline, it has kind of like a constant water input. And then it looks like the slope goes steeper here, and then it goes back to the constant, like almost like these two slopes are the same. Now this one right here is more of a curvy thing happening. So that kind of is like, as the water's filling in, it's speeding up more and more over time is what this looks like it's showing to me. And again, if we pay attention to this right here, the y-axis is the water in the bowl in liters, and then this is over time. So again, we have these similar like linear ones, and we also have some very curvy similar lines going on. I also noticed like some of these have like a little hump there to kind of show that additional water being added and so forth. Another thing I noticed, which is cool, is that most of these start off at having some water in the bowl. Because if your graph starts here at the bottom, for example, like if your graph, oops, my bad. Let Let me use my annotation. So for example, if I had this graph and I did something like this, and then the water went up, if I started down here, that would mean that when the video started, there was like no water in the bowl. So in case if you did start down here, if you want to make some adjustments to your graph, please do. Let me go ahead and undo that. All right, let's go ahead and move on to another example. So as you can see in my teacher screen here, we're gonna see the answer to this water problem after we do a little bit more examples. So let me move you on to the next screen, which is right here. So let me go ahead and play with you what's happening and then y'all can start your sketches. All right, and on your student view, right, you have that little graph. Pay attention to what the y-axis is asking you. It's number of eggs in the carton over time. So go ahead and try to draw a sketch of what's happening, and y'all are free to replay this video on your own screens. I'll give y'all some time to do that. And again, please make sure that you're following along with us. I do see some of us on screen 4 and 1. Make sure that you move along with us to screen 5 and try to draw your graph. All right, as everyone's putting in their sketches, feel free to take a look at what all of us are saying here on the screen. So a trend that I am noticing is I'm noticing that we're all creating decreasing graphs. So over time, the eggs are going down. So it makes sense that I see a lot of decreasing graphs. I see some linear graphs down here. They look like a linear sloping downward. This one's also similar. I mean, it's curving downward. I'm not exactly sure if this was intended to be linear or not. Then I noticed there's some interesting ones that almost look like stairs, like this first one here, Jacqueline, and then Adrian, like a stair looking type of scenarios happening. I go down, I see some more linears. I see a little bit of like that stair thing going on. Okay. And then this one here, I notice it's like line segments separating. And I wonder if that's kind of like pointing to that stair phenomenon that some of you were doing. And again, we see linears and then another kind of stairs thing. So great. I want you to just keep in mind the graph that you put or start thinking about why like certain students have like the stair-like pattern versus how come some of us have a linear thing, some of us have a linear thing with like a little horizontal part going on. We're going to see the solution to this in a bit, so just keep this thought in mind. Let's go ahead and move on to the next scenario. This next scenario looks like this. And there we go. So if I'm going to go ahead and click the video, but then for your graph, it says distance from the camera. So there's a camera recording this guy going around and around on this. I forget what you call those things. But let's go ahead and play the video. All right. So again, there's like a circle motion happening. You want to try to figure out what is the distance from the camera over time as this guy is moving around and around. Again, if anyone knows what that thing is called, let us know. That circle thing that you play with. I'm pretty sure most playgrounds got rid of those, though. It might have been a dangerous thing. And then welcome if you just came in, go to student.desmos.com and put in the code that's up here. It's on the upper left-hand area of the screen. We're going back to that Desmos activity that we did. All right, everyone. I'm going to go ahead and bring us back into this problem, taking a look at what we have here. So I do notice a common trend with most of these. So I notice that there's like up and downs happening, increase, decrease, increase, and decrease, which makes sense because it looks like this guy is like going farther away from the camera, getting closer, farther away and getting closer. So then that makes sense that we're having like an increase in distance, decrease, and so forth. I also noticed that some of these look like sharp kind of corner things. Some of them look more smooth. I also noticed that some of these kind of have at the end of it trailing off to represent when he walked away from the camera. And let's see what else. I noticed that most of these are not starting at 0. Some of them are though. So like having 0 distance from the camera versus some distance from the camera when he started. Okay. Cool. So we're going to go ahead and move on so we could check out some solutions. So if you look, to be honest, number 7, I think they accidentally repeated the screen. So let's not go to number 7. Let's go to number 8. And give me a second, everybody. Go ahead and watch the answer there. I have someone knocking, so wait. Sorry. Hi, y'all. Welcome back. I apologize. Okay, cool. So let's go ahead and check out the solution. Sorry about that, everyone. So the solution looks like, what is it? Let's see. Oh, is it not showing? Which one is it? Oh, right here. No, my bad. Number 8. Y'all go to student, click. Oh, we had a bit of a reflection in the chat. So this is how the first, the one with the water one looks like. Oh, wow. So some of us did get that graph. So I noticed about the slopes. So it looks like the water was like constantly filling, but then when we got more water, the constant increased and then it just went back to the original constant slope. Interesting. So then Francisco said the shape was similar, I just got the timing wrong, same. And I was hoping oh, you were talking about the spinning guy. Yeah, hoping he would fall. Cool, so this is what the answer looks like for the one with the filling water. A lot of us had very similar graph though. Even if it was curvy, that's fine. Let's check out number 9, the one with the eggs though. Let's move on to the next screen. So let's watch this answer. So this one's the most interesting one because we had the most variety. All right, so take a look at how that one looks like and think about that. So it's okay, so Aisha in the chat put, oh, it's a step graph. A lot of you are actually hinting towards the step graph because y'all were making physical steps. Um, But basically, a lot of you were kind of connecting your steps like this, like kind of like a stairs. But then if you did do that, like for example, let me use my little drawing tool. Let's say if I connected this to this, right? This wouldn't be a function, right? It would fail that vertical line test if I had a line here. So in order for this to be a function, a step function specifically, um, it can't have those lines in between. So many of you were very close, and I think it was Florence, it was someone in the thing did do the step graph, so somebody figured it. Let's see. Okay, that's okay. So I got your private chat, that's fine. And then it's the first time I see a step graph on a situation, and that's awesome that you say that, Francisco. It's actually also the first time I see it too, with a situation that kind of makes sense, like, oh, this is a real world way I could graph, like an eggs disappearing from carton. Sure. So yeah, another way we could call this function, by the way, everyone, it's step function, but there's another name. It's called piecewise as well. Piece by piece, it's defined a certain way. We're going to learn a little bit about piecewise functions before the end of this first unit. So this is just a little bit of preview of that type of function. Piecewise, you could also call it step for now. All right, everyone, let's check out the one with the spinning person. Let's see how that one looks like. All right. So I think this one pretty much confirms what a lot of us had. A lot of us had some sharp ones, right? Some sharp points. I feel like that's pretty close to what was actually happening. So the distance was a little bit off. And notice how a lot of you had that ending part of this graph that like he trailed off. And then this is the part where he stopped for a moment and was still. So his distance wasn't moving and then he went off. But a lot of us actually had a very similar graph. So this is awesome. Cool. So I'm just checking the chat. Okay. Great. So by the way, the asynchronous number 4 that you all hopefully turned in, it was due yesterday, Sunday, 11:59 p.m. Had some modeling situations on there. So it's kind of like drawing on this activity here, but it's a little bit before you all finish this activity. So I'm just going to be interested to see what scenarios you all tried to model on there. Again, and it was very open. Like I'm just seeing this I'm just trying to see like more like what are you thinking about when you're modeling situations? Because we're gonna for sure come back to these. So we're gonna go ahead and stop there. The rest of this activity is like a class challenge, things like that. But we're gonna go ahead and finish off here, and we're gonna transition into a Padlet. So I'm gonna go ahead and X this. So that's the conclusion of the activity for us. And we're gonna jump into a Padlet. So on the Padlet, I'd like you to reflect on this activity right now that we did. Think about the functions, the different type of functions we all got to model. Which function scenario was challenging to model? Why? Or you could talk about which function scenario was easiest. Give me a second. All right, y'all. I'm gonna just try to teach despite that. So it's just a lot of things happening. So we're gonna be doing a Padlet right now. You have two different choices of what to respond. What was challenging to model and why? Please don't forget the why. And which scenario was easiest and why. So I'm gonna go ahead and put the Padlet into the chat. And we're period 1. So I'm gonna go ahead and grab period 1's Padlet. And I'm gonna dump it into the chat. Go ahead and try and see if you could edit it. Let me go ahead and open it as well with y'all. Awesome. Go ahead and put in, by the way, if you want credit, if it says anonymous, go ahead and put your name. It's showing anonymous because you're probably not logged into your Gmail. That's the reason. But if it doesn't show your name, please put your name so I could give you credit for this. So again, the question is up here as well. Again, which one was challenging to model and why? Or which function scenario was easiest to model and why? And then we'll take a look at some of these. Or actually, when you're done, just go ahead and take a look at what others are saying about it. And maybe someone else had a similar challenge to you, or someone thought something was easy as well. All right, everyone, these are looking great. These are great reflections of what was the hardest, what was the easiest. Awesome. All right, cool. So I guess some notices for me. Some thought the egg one was easiest, some thought the egg one was the hardest. And a lot of us thought like the first one and the water one were one of the most simplest. All right. Thank you all for your reflections. Go ahead and finish it up if you didn't get a chance to. Again, this will be for a participation credit. All right, let's go ahead and jump off. And I saw somebody put a little smiley face. I had no idea you could insert emojis on here. So let's go ahead and go back to our slides. So thank you for that reflection. We're gonna just pause on modeling. Modeling actually happens always in mathematics. We're gonna continue to model things. It's gonna come back even at the end of our unit. So what I'd like you to do next is let's go ahead and get some paper, pencil, so we could transition into our notes. Notebook and pencil out. We're gonna start to talk about the composition of functions. Let me give you all a second to get yourselves ready. And again, I'm very excited to take a look at your responses to your feedback on that activity that we did on modeling. And we're going to continue to model. It's going to be sprinkled throughout our units. All right, y'all, let's see. Function composition. So again, I don't know if you've seen this before, a little bit or a lot, but we're going to start with a little bit of an introduction on it. Our learning target, hopefully, is I can define and evaluate composite functions. Let's go ahead and write that down. Title. Oh yeah, and don't forget the date. So one thing I kind of forgot here. We're 8:31. So make sure you put the date at the top of your notes. So just always put your date. That way it's kind of easier to find where you're at in your notes. So you could go back and check out when we did certain things. All right, let me give you a few. All right, cool. So hopefully you got this title down and you wrote down the learning target. And keep this a reflection in mind. So this one you don't have to write down. This is just a reflection that we might do today or tomorrow once we're done with our little mini segment on this. So keep this in mind. In your opinion, what's an important step or part when it comes to evaluating a function composition? So you don't have to write this down. It's just keep in mind because we will be answering this as a reflection question. Okay. So we're going to start off our learning on the composition of function with a notice and wonder activity. So this is the notice and wonder. So I went ahead and, one second. Sorry. So I went ahead and I took a screenshot of what function composition can look like with a little bit of color coding. So in the chat, go ahead and put a notice or a wonder about this right here that you see. All right, we see some notice and wonderings coming up in the chat. Again, you want to make sure you put it in. Oh, my bad. Somebody put in the learning target. Okay, cool. Let's go ahead, everyone, and use the chat. I'd like you to take a look at this right here that we have on our screen. And if you could put a notice and wonder into the chat. All right, we have one right here. Notice is that f of x and g of x are being multiplied. So maybe that's something that's, let me try to annotate what that student saw. Maybe they mean this part. They think this part means like multiplication, maybe. Another notice is that there's a whole function being plugged in as x. Ooh, that's a good notice. Let me just circle that. So there's a whole function being substituted in. I think they mean like this. Like, instead of substituting a number, they notice that a whole function is being plugged in. That's a good notice one. All right, let's see what else we have. I noticed that g of x is being plugged into the f of x equation and vice versa. That's true. So noticing that g of x gets plugged into f, and over here, f of x got plugged into g. We have another wonder that was sent privately is, I wonder what the red and blue highlights mean. That's a good observation. What does the color coding mean? How does it help us as students? So go ahead, and if you didn't get a chance, please put your notice and wonder into the chat. If you haven't yet, I mean. But these are so far so good, very great. And we have an answer perhaps to the notice and wonder question about what are the red and the blue highlights. And then Francisco in the chat put, I think the red is the f of x function. So red is color coded to represent f of x, and blue was color coded to represent g of x. I mean, I think so. That's why up here it looks color coded and it's repeated down here. Awesome. All right, cool. So I'm going to pause here and see if we have any other notices and wonders about this. And again, you want to make sure you put it in there to let me know that you're here and that you're following along with us. And then I wonder what they represent. I wonder why you get two different answers and what they mean. I wonder why you got two different answers and what they mean. How do you know what to plug in? Those are good questions. I know, right? There are two different answers. Yeah, notice there are two different because this one's plus 17 and plus 7. Why would both equations at the end start with 3x? That's true. At the end, they do. Like at first when I looked at this, like sometimes I feel like I have, I sometimes skip numbers when I look at them in my head. So if I see 7 and 17, I might think they're the same. But looking carefully, yeah, they do have the first part the same, but not the second part. Another wonder that we have is, can the equations be simplified further? That's another wonder we have. All right. So far, so good. And again, if you did not get to share your wonder or notice, please make sure that you could either send it to me privately, right? Or you could send it in the chat. Preferably in the chat, because it helps, like if you have the same wonder, to see someone else is validating, like, oh, I'm wondering the same thing. And it kind of helps that we're all at like either in the same spot or different spot in our understanding. So what is it? So this is actually what we're going to try to learn to do here today. And some of these questions that were brought up, some of them were answered. So yes, the color coding is to represent the different functions. So here, f of x was made red, so you could see what f of x is doing. And g of x was made blue, so you could see what's happening when you're substituting in for g of x. All right, let's go ahead and transition us. Okay, let's write this down in our notes, everybody. So what does it mean to compose functions? So here's the definition. Composing functions means that the output of one function becomes the input of another function. So I noticed that in the chat, one of you said, I noticed that a whole function is being plugged into another instead of a number, right? That's what it means when you take the output, which is like a whole function, and you put it in as the input of another function. So that was already brought up, and that's exactly what composing a function means. And functions represented as equations can also be composed. This can be thought of stacking function machines. So sometimes you could describe composing functions with something called a function machine. It's not really a machine, it's more like a visual so that you can visually see what's happening. We're going to be looking at a function machine in a second to help us understand how to do function compositions. You've also maybe have seen a drawing of a function machine like in algebra 2 or in algebra 1 for like functions like, oh, 3 goes into the machine, the output is this. But we'll see. It's okay if you're not familiar with the concept. All right, I'm gonna go ahead and move us on to the next slide. Okay, first, if we could all draw this function machine on your notebook paper, please. So, and by the way, it doesn't have to be fancy. These machine boxes, whatever, can just be squares. That's fine. You could put X going into and go ahead and copy down this function. And then here going into, so the arrows and then a box and then the arrow G of f of X. So just go ahead and copy down this visual. And then if you are taking notes, like some of you are typing out your notes, you could even take a screenshot of the visual, saves you time. And as you all are drawing that down, let me go ahead and just describe what's happening here. So the visual to the right, it shows that there are two functions that are being composed. The first function is f of x equals 4x plus 7. And the second function down here is g of x equals x squared minus 3. And at the end of the function machine, your output is g of f of x. So whenever you see a parentheses, you say of. So you notice how I'm like g of f of x. So that's how you would read that. And notice how up here, I already started color coding this. So I made the F red and the G is purple. For me, this helps to follow along what's happening. So let me just pause to give you all some time to draw the function machine. Okay, so notice that what goes in first is x. Notice how x gets dropped in first and then it gets plugged into f of x. Then whatever the output it is gets dropped into g of x and then it will give you the answer. So that's just a notice. Let's do an example of a problem. So it says evaluate g of f of 1. So the first thing that goes in is your x. In this case, it's 1 that's going to be plugged in. But you could also color code to help you. So again, I made G purple, F red. I mean, if you don't have any crayons or color or highlight, that's okay. You don't have to color code it. But let me show you what I mean. So instead of X, we have, let me just erase, it's like 1. So 1 is going to get dropped into the function machine. So 1 is going to get plugged into f first. Basically, you do this first, f of 1. So if you plug in 1 right here for x, what do you get as your output? You could use the chat. If I plug in 1 right there, what do I get as the output of the function? We have one answer, 11, 11. Let's see if we do get 11. So 3 of us think 11, 4 of us think 11. So let me go to the side for those of you who are maybe a little bit confused, like, okay, how are they getting 11? So 1 got dropped in. So that means 1 gets plugged in for x right here. So you're going to do 4 times 1 instead of x plus 7. So 4 times 1 plus 7, that's just 4 plus 7. I think that does give you 11. So that's right. So then our next thing would be this. Notice how I rewrote this expression. Instead of f of 1, I now rewrote that as g of 11. Because now my next step is, now that I got 11, is I'm going to drop it into the function machine. And I'm going to plug in 11 for x. So that's my next step. So when you plug in 11 for x into g, right, into this last function, what do I get as my final output? What is g of 11? So we have an answer of 118. Let's see what anyone else thinks what we should get. So 118, or what other answers are we getting when you plug in 11? 2 of us are thinking 118. All right, everyone. So let's see what the answer is. Thank you. I definitely want to just give everyone processing time to figure out this problem as well. And again, remember, you want to make sure that you're letting us know if you're getting something different, right? So far what we got is 118. So basically, if you take 11, you'll plug it into here. Let me just draw an arrow to show you. So 11 squared minus 3. 11 squared, that's 11 times 11. That's 121 minus 3. And I believe that does indeed give us 118. And that would be the answer. The answer here would be 118. Let me know if anyone has any questions on the chat on how we got 118. Yes, so that's a great clarifying question, Francisco. So the answer of f of x is what we plug into g of x. That's correct. So you always start in the inner part. I circled the inside first, and then let me also just like draw on here, but it's like whatever you plug in here gets plugged into G, like an arrow like that. So you always start inner and then you plug into the outer. That's going to be the strategy that we'll be doing. So we're not always going to be drawing function machines. We're just going to look at it and develop how to do it from there. Instead of drawing these machines, the machines just help if you're a visual style of a learner to help you draw this out. So you're free to draw those if you need it. All right, let me go ahead and clear my drawings. Let's try another one. Let's try another example. So we're using the same one, but now we want to evaluate what g of f of x is. Now we're not plugging in anything to x. We just want to figure out what is this function composition. So there's nothing that we're going to like drop in there. Instead, what we're going to be doing, let me go ahead and draw, is since there's no x exactly that we're plugging in here, we're just going to take my function f and we're going to plug that whole function in right here. That's what we're going to do. And that's what y'all kind of noticed that was happening in the notice and wonder. So let's do it. So notice how instead of f of x, what I wrote on the inside of the parentheses is what f of x was. So f of x was given to us. It's right here, and let me circle it over here. So that got plugged in here because that's what f of x is. The next step that's going to happen is, well, what's g? If you look down here, this is what g of x is. I'm going to circle it. Instead of x, though, you're going to plug in that whole function of f of x. Take a look at how that looks like. Notice how instead of x, I plugged in 4x plus 7 into my equation. Let me just pause here and see if there's any questions in the chat, though, so far of what we're doing. All right. So now the next step is simplify. So this squared means you write this 2 times. And remember, when you write this 2 times, you could use that box method. Let me show you what I mean right here. So I multiplied this 2 times and I used the box method to get this answer down here. That's over here. Then all I did to simplify is I combined like terms at the end. So 49 minus 3 gave me 46. So that's what I did for the last part. And then this is my final answer. I'm just going to go ahead and stop here. This on example 2, and we're going to continue to finish our notes on function composition in our next class meeting. So your homework, asynchronous number 5, is all about function composition. So you can refer to your notes, or if you look at that document, I put in like little video help and also like a website that you could scroll through and learn a little bit of more information. So the homework is not for you to get it 100% right. I want to see how right now you're thinking about this. This is just an introduction, so I want you to just try your best. Does anyone have any questions on that so far before we head out? Nope? Okay. Awesome. And I don't recall if I see you all tomorrow or not. I'm kind of hoping for that. Get it, but you might see me tomorrow or it's on Wednesday. Okay, here we go. Y'all will see me tomorrow. So actually, oh, Mr. Wade is here in the chat. Cool. Then feel free to unmute yourself too, Mr. Wade, if you want to introduce yourself. All right, y'all. Thank you all for being here. And again, if you have any questions, any clarifications, we'll be meeting tomorrow. We'll finish up these notes. So you should have some support for the homework. All right, y'all. Bye, y'all. And I'm happy that you came in, Miles. Bye, everybody. Sorry for all the noise background I had.